Alright, so in this video we will go over transformations of functions. As you see, I listed above are all the different names that a function can possibly be called and all the different parameters and what they do. Starting from the left, we see that the plus or minus outside of our function always is a reflection horizontally over the x-axis. The a in front of the function is a vertical stretch or a vertical compression determined by if a is greater than 1 or if a is between 0 and 1. If it's greater than 1, it's a vertical stretch, so we're stretching our function. And if it's between 0 and 1, we're vertically compressing that function. Inside our function, the plus and minus attached to the variable is a reflection over the y-axis. The h, or anything that it's added or subtracted from our x, would move our function left or right. If there's a minus h, we move the function to the right. If there's a plus h, we move our function to the left. We must remember this. This is where students always make mistakes. A minus moves to the right, a plus moves to the left. And I've already showed you why that is true in class. And then finally, outside of our function, the plus or minus k will move our function either up or move the function down, depending if it's plus, up, minus, down. So I want to go over a quick example. The reason why we're keeping it in function notation, such as naming the function f of x, is because if we learn the rules in function notation, we could apply it to any function that we are given. So the example says, transform f of x up 3 units, left 5 units, and reflect over the y-axis. So what would our new function be called? Now I'll do it step by step so we can see all the different types of names as we get to our final naming of our function. So in step 1, let's just keep f of x. So we remember that is our parent function. So we'll name this parent function, or our starting function, parent function. It's the most simplistic form of the function. Our step 2 would be, let's move it up 3 units. So move up 3 units. So what would we call this new function? Well, the new function, since moving up is determined by our k value, we see our k value is outside of our function. So the new name would be f of x, fix that parentheses, good, plus 3. That's the name of our function if we moved it up 3 units. Alright, so for our next step, step 3, we will be moving our function left 5 units. So move left 5 units. We are now going to be working with our f of x plus 3. And to move left, we have to use what parameter? Well, it's the parameter h. It's adding or subtracting a value from our x. So since we want to move to the left, left must be a what? It must be a positive h value. So our new name now becomes f x plus 5 plus 3. So that name now shows that the function has moved 3 units up and left 5 units. Finally, our step 4, we want to reflect over the y-axis. So to reflect over y-axis, we must do what? If we look at all of our possibilities, we see reflection of the y-axis must be a negative in front of the x. Okay? So to write that, we see our new name is f, a negative in front of the x, plus 5, outside the function out, plus 3. I'll square this. Here is our final answer. The new name of our function is f of, in parentheses, negative x plus 5, close parentheses, plus 3. We have successfully transformed our f of x, or our parent function, up 3 units, left 5 units, and reflected that function over the y-axis. Alright, so we're going to try another example. This time we're actually going to name a function. So instead of using function notation as f of x, we will now give it a name, an actual function, which is absolute value x. So we're going to transform f of x equals absolute value x, write 2 units, reflect over the x-axis, and vertically stretch by a factor of 2. Okay, so how do we do this? Well, we do it the same way as we just did with function notation. So we are going to do step 1, we are going to write our parent function. In this case, absolute value x is going to be called our parent function. So I'll write parent function. It's the most simplistic function of absolute value, so it's absolute value x, parent function. Okay. Our step 2 would be to move it right 2 units. So how do we do that? Well, to move right, we look at all of our parameters and we see to move right, we need a negative h value, and it's inside the function. So what's inside of our function? Well, right now, inside of our function, we have an x, that's it. So we have 2 walls, or 2 lines, which is the absolute value sign, and we have an x. So we need to get inside that function. So we want to move right 2 units. So I'll say move right 2 units. Okay, so we'll get inside the absolute value, and we will name the new function absolute value x. Now to move right, we need a what value? A negative. So it's negative 2 or a minus 2. Minus 2. Close the absolute value. That's where we are on the graph right now. We're at absolute value x minus 2, which is 2 units away from our parent function, absolute value x. Alright, so what's our third step? Well, our third step is to reflect over the x-axis. So we want to reflect this now. Reflect over x-axis. Now, how do we do that? Again, we look at our chart, and we see to horizontally reflect, or reflect over the x-axis, we want a negative in front of our a. Our a is outside of our function, and there's a negative there. So, we know that to reflect over the x-axis, we need to add the negative outside the function. So let's write our function, which is absolute value x minus 2 now. And we need to now add a minus outside the function. That will now reflect our function of absolute value x minus 2 over the x-axis, and our new name now becomes negative absolute value x minus 2. And finally, our step number 4 is we want to vertically stretch by a factor of 2. So we're going to vertical stretch factor 2. And what does that now change? How does that change our function's naming? Well, the factor of 2, the vertical stretch, is the parameter a. So it's greater than 1, so it must be a vertical stretch. So the 2 must come outside of our function. So if our function was negative absolute value x minus 2, our new function must be negative 2 absolute value x minus 2. And we will square that, because that is our final answer. So if I wanted to graph this, I could graph this really quick so you know exactly what we were doing, and I could use 2 color lines. If I was to make my, let me go back to this color. If I was to make my x and y plot, what would our f of x function be? What's our parent function? Absolute value x. So what does that look like? Well, I'll make that in red. That's what our absolute value x function would look like, and I'll label it as absolute value x. That was our original That was our original function. So that was this one right here. That was number 1. I'll put a dot. That was number 1. Now, what was our final function? Well, the final function was -2 absolute value x minus 2. So let's draw that. Let's put that in purple. So what did we do? We moved left 2 units. So let's get 2 units. Did we move to the left or the right? We moved right 2 units. So let's get 2 units to the right. So there's 1 unit. There's 2 units. Okay, so our point is right there. We reflected over the x-axis. And we vertically stretch by a factor of 2. So let me, I'll graph all of these. So the second graph we'll put in purple. We'll put in purple. And that was to move right 2 units. X, absolute value x minus 2. So in purple, we'll draw the new graph. There is our new graph. And that name was absolute value x minus 2. Okay? Now step 3 said reflect over the x-axis. So let's make that in blue. Put a little dot. Our blue is going to be a reflection over the x-axis. So everything from our absolute value x minus 2 stays the same, except we flip it. We flip it over the x-axis. So it looks something like this. And we can name this as absolute value x minus 2. And remember, it needs to have a negative outside. And finally, our final step, I'll do it in green. It said a vertical stretch of factor 2. Now in class, remember I told you when you vertically stretch absolute value x, it's like putting your 2 hands on the 2 endpoints. Now we realize there is no endpoints because absolute value x goes on forever. But we grab our 2 endpoints and we pull up. And if we were to pull up, what would happen? Well, absolute value x, or in this case, negative absolute value x minus 2, would get skinnier. So our graph should now look like this. And our new name would be -2 absolute value x minus 2. Now in later videos, we will get into exactly what that vertical stretch or compression does. We remember in class, we went over finding the slope of the right-hand branch. That would equal your A value, but we will get into that in our later videos. For right now, we should have learned how to name functions and then how to transform those functions from our simplest function known as our parent function. All these rules apply to any function such as x, x squared, x cubed, and so forth. It even applies to sine, cosine, and tangent, or any other function that we will deal with this year.